Hello and welcome back, and congratulations on being here to enhance your learning and doing your job. So good for you. This is compare and order rational numbers. So we learned about rational numbers last time, knowing that those are numbers that can be written as fractions, and now we want to be able to compare and order them in a certain way. So our little review of vocab here. A numerator is the number on top of a fraction. Well, that's pretty basic, but it's the part of a number represented. Okay, so it's the part maybe that you have. Denominator is the bottom of a fraction, but that is the number of pieces that a whole is split into. Okay, so we'll think about those things as we go. So a little preview thinking and how estimation might help us here. These numbers are a little blurry, so I'm going to write them out. Buttered popcorn here. Kip surveyed his class to find out what kind of popcorn students liked best, and the results are found in the table. So buttered popcorn, it looks like is 5/12. Cheddar, it looks like is 3/16. And caramel is 1/6. Is that 1/6 or is it 1/8? Yikes. 1/8, I believe. 1/8, and then plain is 1/6. You know, I could check. I could see that they all add up to one whole. We'll go with it though, because I think that's what it says. If you think differently, let me know. So, question 1 here, and all of these questions help us, how do we use data to come up with statements or assumptions or understand the information that we're presented with. Do more or less than half of the students prefer buttered popcorn? So more or less than half preferring buttered. So what I do notice is that buttered is 5 out of 12 students. And what I can say is that I know that 6 out of 12 is 1/2. And so since 5 is less than 6, that is less than half. So we would say less than half of the students prefer buttered popcorn, which is wild because you think everyone loves buttered popcorn, right? Second one says, which category is preferred by more students out of these two, caramel or plain? So then looking at that, we have 1/8 compared to 1/6. So you think, well, the more pieces it's cut into, if you think about this as a number of people, your denominator, we think 8 is bigger, but it's 1 out of every 8 versus 1 out of every 6. So I could do some cross products to check. I could change them to decimals. So what I know, though, is if I multiply across, this is 6 and this is 8. So if these were equivalent fractions, 6 out of 48 people compared to 8 out of 48 people would prefer that. So we know that the 1/6, that plain, is more. So more people prefer plain. Another one then, which category of popcorn is preferred by about 1/4 of the class? So I'm thinking about this and I look at, well, I already know that 5/12 was close to 1/2. 3/16 I know is fairly close. It's 1/16 away from 4/16, which is equal to 1/4. So I would say that is cheddar. So if you were to use estimation, how would we order these from least to greatest? The least liked preference to the greatest. When they say estimation, what they want you to do is not compute. They don't want you to change them to have common denominators. So it's using that tool of kind of your what's closer to 0, what's closer to half, what's closer to 1, using those benchmarks to help you. So see if you can order those least to greatest, and then we'll check those. Just remind me. So let's get to the good stuff here. That was good stuff too. We're going to compare positive rational numbers. So we're looking at just positives here. So there are lots of different ways that you can do this. First of all, we need to know how we read these symbols here. And I think we all just we forget sometimes. But what we do is that we read left to right. So when you think you have it, make sure you read your number sentence left to right to make sure. Another thing that we need to remember is that left is less. If you think about a number line, the further left you are on a number line, the smaller it is. So we read this symbol as less than, and we read this symbol as greater than, reading left to right. So if we had 5/8 compared to 3/4, both of them are more than 1/2. So this one, some people might say, is 1 away, but that doesn't really matter because the pieces are smaller. So here are some strategies that I'll tell you that you're going to use throughout this that I'm going to show you Different strategies to compare rational numbers, or you could change them to decimals, and then you could compare them to the place value. Make sure they're each out of the hundredths or out of the thousandths. You can use your cross products, and that would change it to have a common denominator, but not necessarily the least common denominator. And then you could find the least common denominator and compare them, then compare the numerators. And we'll talk about all of those, and they should ring a bell. So on this one, what I'm going to do is I'm going to compare, I know that this 4 is a factor of 8, so this could be written as a equivalent fraction with a denominator of 8 if I just multiply this by 2. Then keeping it equal, I do the same on the top. So that's 6/8. Well, I can see that 6 is bigger than 5. So even though I read that backwards, when I put my symbol in, I need to read left to right. So 5/8 is less than 3/4. If you feel ready, go ahead and try. Otherwise, stick around for a couple and then check. So same thing, I'm going to do a couple different strategies here. On this one, I know again that 4 is a factor of 12. So this can be written as a common factor. I can change this both by a multiple of 3. So this is the same as 9/12. 9 is greater than 7/12. 9/12 is. Over here, 6 and 8. So if I did the cross products, that would be giving those a multiple of 48 on the bottom. So I can just do the cross products and check. 6 times 7 is 42. 8 times 5 is 40. So that would just mean that 40 48ths to 42 48ths. 5/6 is less than 7/8. And one more, you could again change them to fractions. Since they're, or decimals, since they're both whole numbers here, I know it's 1 and something. So again, I might just do my cross products here. 9 times 2 is 18. 5 times 4 is 20. So I know that 1 and 4/9 is greater than 1 and 2/5. All right, bear with me now. I know I'm rambling on a little bit, but that's because this is important stuff and we want to know how it works and why it works, not just following steps. So rewind where you need to. So comparing decimals now. So if you have a fraction and a decimal, we need to remember that we can change a fraction to a decimal, remember, by dividing. So numerator over denominator is the same as numerator divided by denominator, which is the same as numerator divided by denominator. So here, what I know is if I divide 8 divided by 9, I get 8/10 repeating. Since this is written as a decimal, the hundredths place, you can compare that, is greater in this number than it is here. So we would say that 8/9 is greater than 8/10. All right. So again, you can make decimals, just divide and compare. So here, 1/3, I know if I did this, I would do 1 divided by 3. That's a decimal that I kind of remember at this point. It's 3/10 repeating. So if I can't totally tell right there, and they might look equal, but I know that repeating sign means that it keeps going. And this just has zeros behind it. So that would mean that 1/3 is greater than just 3/10. When, for this next one, I could divide 11 divided by 50, or I could change it to that common denominator of 100 by multiplying by 2. So then I get 22 hundredths. I write what I read it as 22 hundredths in the hundredths place. So I see that those are actually equal rational numbers. One more for this one. I'm probably going to change to a decimal. So I'm going to do 2. I know it's 2 point something. I'm going to do 5 divided by 12. And so 12 goes into 50 4 times for 48. 2 left over. I bring this down. It goes in there once. So already, it's going to keep going. This fraction is not going to be super nice. And I could keep going. But I already know it's 2.41 something. And I can tell that 2 is greater than 1. So 2 and 5/12 is less than 2 and 42 hundredths. So you have to make those judgments as you go. All right, you're doing great. Keep with it. Take a break when you need to. Rewind when you need to. Now let's compare negative rational numbers. So just as positive and negative rational numbers, they can be used on a number line, right? So we know that we have numbers that are to the right of a number line, which are positive, and to the left, which are negative. Fractions are on a number line, decimals are on a number line, same concept. So we can use a number line to help us here. So if I want to graph negative 2 4/10 compared to negative 2 45/100, for me, I know that I like to write them to the same place value. So I'm going to put a 0 right in there to compare them at the end of that 2 4/10. And then here's this little backwards thinking. It's that absolute value, right? So the greater absolute value of a negative, that's the further left it is, or the more negative it is, the further left. So here I see, okay, this number looks bigger, but that would mean it'd be further left on a number line compared to here. So negative 2 4/10 is actually greater than negative 2 45/100. So remember that concept. Because that is further right on a number line, we know that it is greater than that. So remember that left is less. Gets a little tricky with those, so pay attention to that absolute value. All right, you guys are doing an amazing job. See if you can try that now. If we have a negative here, you're really just comparing your fractions, which is nice when they're not decimals. Because, right, the more negative, the more negative. So this one just says kind of if you want to look at it, putting your negative with that numerator. So kind of looking like this instead. You're really just comparing those numerators. And I know that negative 7 is further left on a number line. So that this would be less than that. Okay. All right, a little bit more. And let's see if you can try this now using what you know. The average life expectancy of males for several countries are shown in this table here. We're going to order the countries least to greatest by male life expectancy, expressing the number as a decimal. So here some of them already are as a decimal, right? 76 9/10 I know is the same as this. So I just kind of want to write it as both. So I know 74 4/5 I know that is the same as 74, and if you multiply that by 2, right, to make it out of tenths, 8/10. So then I can just write what I read. 75 1/3. I know 1/3 is that repeating decimal of 3/10 repeating. 75 is just 75. You could throw a 0 on the end after the decimal. And then 74 1/4. Again, I know it's 74 1/4, which is the same as 74 25/100, which I read as 74 25/100. So now if I have all the decimal ones, and you've got to look kind of at the end here, if they're all in the same form, it's easier to compare them. So now, seeing what their decimal is, can you order them least to greatest in this chart here? So the least long to live to the longest to live in that order, and then we'll check those together. One more that you might want to try before you come to check with me is Sophia has 5 wrenches measuring 3/8 inch, 1/4 inch, 5/16, 1/2, and 3/4. What's the order of the measures from least to greatest? So again, when you order these, I want you to order them in the original values, even though you might have to convert them to compare. And how you want to compare these, right? To make sure we know, could change them to decimals, that's more work. Why don't you find a common denominator and see if you can do that? So I'm looking at this and I'm looking at 8, 4, 16, 2, 4. 16 is a common multiple of all of those. So that would be a great thing to do. This would be equal to, if I change this, times 2, so 6/16. If I change this by 4, that'd be 4/16. 5/16 can stay the same. 1/2 would be 8/16. 3/4 would be 12/16. So if they're all out of 16ths, you can order them least to greatest, but then you should write them in the original values. So what they were compared to. So I can tell, well, the least out of 16 is that 1/4. Then I have a 5/16, right? 5/16. Yes. And then I have more 6/16. So that originally was 3/8 of an inch. And after that I have an 8, which is 1/2 inch. And then I have that 3/4. So that is those ordered least to greatest in their original values after I compared them. So a lot of this isn't super new. It's comparing. It does take a lot of thinking and slowing down. So do your best. We'll see you soon.